60 turns here, 80 turns here. I'm going to say this has 100 turns.
Okay.
So each one of these gives me an opportunity to transformers are they're super efficient.
Yes.
So having a transformer that's broken out like this, I can get a certain amount of voltage here, a certain amount of voltage here. Think about a PC computer. On your typical desktop computer, you have 3 different voltages that's being supplied. You have 12 volts, 5 volts, and 3.3 volts.
Yes.
All of that is
Same concept.
well, that's exactly what's happening. There's that transformer that's in that power supply, and when you have that 24 pin or whatever, it's going off of a transformer that's putting out those respective voltages.
Got it.
So this is our primary, and this is our secondary.
Right.
So the first thing is okay, we have to figure out, we know that on our primary side we have 240 volts. The catch is how to solve for what voltage is being put out on the secondary side. First catch is to solve for the turn ratio. So turn ratio is the number of turns on the primary, NP, against the number on the secondary side.
Got it.
So that's step one. So my first step would be to say 300 divided by 20. So 300 divided by 20
16.
gives me the turn ratio TR equals 15.
Okay.
So we're going to do the same thing here. Turn ratio 300 divided by 60. That's equal to 5. 80. 3.75. What'd you say there, Jay?
Hey.
Happy Friday to you.
Yes, sir. I'm assuming John Boy went on home.
He did. I'm not too far behind him.
That'd be 3.
And that would be 3.
Okay.
So that's step one. To solve for our turn ratio.
That's easy.
So then the next thing that we do is we take our 200, our primary voltage, and we divide it by the turn ratio.
Got it.
So we have 240 volts, and we divide that by 15. That gives us a voltage of 16. For this 60, is 240 divided by 5. That would be 48. Volts, 3.75, 64 volts, 80 volts. It's as simple as that.
And you don't add the 16 to the 48. They just stay the way they are.
No, but I could tie them together to get it would be 50, 64. Because I could tie them together. I could tie these two together to get a higher voltage, or I could tie them all together and it would be the 80 to 64 to 48 and 60. So that's one of the beautiful things about it. You have a lot of flexibility when you're working with the transformer. So it gives you a lot of a lot of different ways to go with what.
So there's
voltage
no
I can get.
resistance here.
Well,
No.
so well, of course, because you have the coils, there is not to the point where you're doing those type of calculations.
There is no Ohm's law in a transformer.
Not in the conventional sense.
Okay.
When you're dealing with transformers, you're primarily dealing with what am I going to get on the output side, on the secondary side, because this is the side that everyone uses. So like with your laptop, your power supply has a transformer built in. So if it's it's got 120 volts AC going in, and that voltage is, so it's a waveform.
Right.
And then there's a bridge rectifier. It's a circuit that consists of 4 diodes. And so what that does is it cuts out the negative waveform.
Interesting.
So then I just left with this. So that's kind of what it ends up looking like. And then it goes, so then that signal, or this part of the signal goes through what they refer to as an RC circuit, a resistive capacitor circuit. And it may go through another series of diodes that are
So it takes a whole lot of extra equipment to come up with.
In other words, because at the end of the day, this is what you want.
Right. A clean.
A straight line of voltage. And so it cuts out the negative waveform, because could you imagine trying to watch a TV show and your picture is going
Right, so that waveform is considered noisy or dirty? Is that correct?
It's not necessarily considered noise. It's just, it has to have that part of the waveform, because you go positive, negative, back to zero, positive, back to zero, negative.
Got it.
And so it has to eliminate the negative voltage, because DC is typically, not that you can't see a negative voltage in DC, but it doesn't change. If it's a negative voltage, it's constant. Same thing with the positive DC voltage. So, and that's ultimately what you're trying to get to. So it goes through some circuitry to go from an AC waveform to get it to just a flat DC voltage.
Got it. So after a transformer, it's not just transforming it to a lower voltage. It's
so in this instance, so you have step-up transformers and step-down transformers.
Got it.
More often than not, the transformers that you're going to be dealing with are step-down. So it's going to step your voltage from a higher voltage level to something that's a little bit more manageable and a little bit safer to use electrically.
Excellent.
That's not to say that there aren't instances where step-up transformers where you have a lower voltage coming in, and so your windings are typically reversed. You'll have a lower winding count on your primary side, and you'll have higher windings on the secondary side to pull that voltage up.
Because what I had running in my head when I first saw this was copper wire, or copper tube. So a copper tube on a straight only had, just for giggles, a gallon of water, but when you coil it, it's going to accept about maybe say 100 gallons.
And electricity moves like water, so that's not a bad analogy. And that's where the efficiency comes in. So the difference with the coils, so the fewer number of coils that you have present, so when electricity moves through a coil, it creates a counter electromagnetic field. So the more windings you have, the greater the electromagnetic field, and the more resistant, because in AC, in AC, it resists the electromagnetic field, the current that's generated because of the voltage, the current that's moving through it, resists the change to the current that's being injected into the circuit.
Got it.
So you have an amount of current that's going through the circuit, and as the current moves through the windings and that electromagnetic field is created, it resists, because the external current is always trying to change that. The field kind of tries to work, it pushes against that current in lieu of its own.
Got it.
It's much happier with the current that it's creating versus the current that's trying to move through the windings.
Okay.
But
That's awesome.
that is pretty much Transformers in a nutshell.
That's amazing. Thank you.